August 1943. The sky over Schweinfurt turns into a graveyard. 60 American bombers fall in a single mission, shattered and burning before they could even reach their target. A brutal lesson written in smoke and wreckage. An unescorted bomber cannot survive over a defended industrial city. 78 years later, a B-21 Raider rolled out of a factory in Palmdale, California, and not a single public document described what it could do or where it could strike from. Between those two moments, 12 generations of aircraft, millions of crew hours inside cramped fuselages, and one question that never changed: what is the ultimate price we are willing to pay to deliver a weapon to its target? The answer begins with a theory. In 1941, American air doctrine had a name: AWPD-1. Strike the enemy's industrial arteries from altitude, collapse his war machine, win without a ground invasion. 2 aircraft were built to carry that theory into reality, and both arrived with the same fatal assumption baked in. The B-17 Flying Fortress entered design in 1934. Serial variants reached squadrons by 1939. The name wasn't military language. It was a journalist's phrase from a 1935 air show. But somewhere between the drawing board and Germany, that label became doctrine. The 8th Air Force was convinced. Tight formations, 10 gun positions, armored stations, no escort required. The machine would protect itself. October 14, 1943, ended that argument. 291 B-17s launched toward Schweinfurt and its ball-bearing factories. 60 never returned. 17 more landed too damaged to fly again. 28% of the strike force gone in a single afternoon. Deep penetration raids were quietly halted. No obituary was written for the self-defense doctrine. The numbers said everything. Inside those aircraft, the cost was physical. At 25,000 feet, unprotected tail positions dropped to minus 40 degrees. Oxygen masks froze against skin. The ball turret gunner wore no parachute. There was no room for one. Average time before a crew suffered its first serious damage over Germany in 1943, 9 missions. Number required to rotate home, 25. While B-17 losses climbed, the B-24 Liberator filled the sky beside it. Better range, higher speed, a more efficient wing. Ford's Willow Run eventually produced one B-24 every 59 minutes, 18,482 machines by the war's end. The largest production run of any American combat aircraft in history. Crews called it the flying coffin. The Davis wing generated lift until it didn't. When damaged, it gave no warning. Fires, uncontrolled dives, tail booms cracking under stress. What saved strategic bombing wasn't better design. It was industrial scale. By 1944, over 6,000 B-24s flew simultaneously. Losses became arithmetic, brutal, tallied, and replaceable. Both aircraft had reached their ceiling. A factory, a rail yard, a port, yes. Breaking a nation alone, beyond fighter range, no. Quietly, in Kansas and Nebraska, a different machine was taking shape. Pressurized cabins, remote-controlled turrets, range that exceeded anything previously built. It wasn't designed for the Reich. It was designed for Japan, and for a weapon no one had yet used in combat. That machine had a name, B-29 Super Fortress, and the specification behind it was, by any engineering standard of 1940, a fantasy. Range of 3,300 miles, a 20,000-pound bomb load, cruise speed above 350 miles per hour, pressurized cabins for a crew of 11. Boeing's engineers accepted the contract and quietly noted among themselves that several of those requirements could not simultaneously exist in one aircraft. They built it anyway. Total program cost exceeded the Manhattan Project. The B-29 delivered on its promises and concealed its failures until the worst possible moments. The Wright R-3350 engines were prone to overheating and fire, especially on takeoff under full load. In February 1943, Boeing's chief test pilot, Eddie Allen, lost an engine to fire on a test flight over Seattle. The aircraft went down into a meatpacking plant. Allen and his entire crew died. The problem was never fully resolved. Pilots flying combat missions over the Pacific simply knew Engine failure over open ocean meant near-certain death. On August 6, 1945, a silver plate-modified B-29 named Enola Gay dropped Little Boy on Hiroshima. 3 days later, a second aircraft released Fat Man over Nagasaki. The B-29 became the only aircraft in history to deliver nuclear weapons in combat, and in doing so, it permanently altered what the word bomber meant. But the war ended, and the B-29 did not retire. It flew into Korea. There, the MiG-15 was waiting. The Soviet jet attacked from above and behind, exactly where the B-29's gun arcs were weakest. In October 1951, during what crews called Black Week, loss rates surpassed the worst days over the Reich. Daytime raids were suspended. The most advanced bomber of its era had become tactically obsolete in less than 6 years. The B-36 Peacemaker was already in service. Built around a specification written in 1941, when reaching Berlin from American soil seemed like the only worthy ambition. Convair delivered a machine of absurd scale, a 230-foot wingspan, 6 pusher piston engines, supplemented by 4 jet pods on later variants. The phrase that followed it everywhere: 6 turning, 4 burning. From 1948 to 1953, the B-36 was the sole American aircraft capable of striking deep Soviet territory and returning without a forward base. It never flew a combat mission. Its piston engines overheated in the pusher configuration. Maintenance consumed the crews who serviced it, climbing onto the wing in Texas summer heat, working beneath cowlings that dripped oil downward. And when the MiG-15 appeared over Korea, the question no one answered officially became unavoidable. Could the B-36 actually survive Soviet air defenses? The revolt of the admirals, in 1949, had already made that doubt public. The answer never came. The B-36 began to be replaced before all its squadrons were even fully equipped. It had solved one problem: reach. But it had done so with the wrong engine, in the wrong decade. Somewhere in a Boeing hotel room in Dayton, Ohio, engineers were already sketching something else entirely. That sketch became the B-47 Stratojet. In a Dayton hotel room in October 1948, Boeing engineers rewrote their entire proposal over a single weekend, scrapping the turboprop concept and committing to a pure jet with a swept wing borrowed from captured German research data. The result was unlike anything flying at the time: 6 J-47 engines and underwing pods, a 35-degree sweep, bicycle landing gear, a braking parachute on touchdown. First flight, December 1947. By peak deployment, SAC operated over 1,800 of them simultaneously. The B-47 was built around one idea: fly faster and higher than any interceptor can reach. At 600 miles per hour, above 40,000 feet, it outran everything the Soviet Union had in the early 1950s. Curtis LeMay built SAC's entire strike doctrine around that speed advantage. The problem was range. Without refueling, the B-47 couldn't reach the Soviet heartland from American soil. That meant forward bases: Britain, Spain, Morocco, Japan. Over 1,800 aircraft, each dependent on a network of overseas airfields that were themselves exposed targets in any first strike scenario. The doctrine of rapid nuclear retaliation rested on infrastructure that could be destroyed before a single B-47 ever launched. Then the MiG-19 arrived. Then early variants of the S-75 surface-to-air missile. By 1956, the altitude advantage that justified everything was gone. Internal SAC assessments found that a significant portion of B-47s couldn't meet required alert response times due to maintenance backlogs and parts shortages. The bomber that officially formed the backbone of American nuclear deterrence had a real-world readiness rate far below what was reported upward through the chain of command. The B-52 Stratofortress solved what the B-47 couldn't: range over 8,700 miles without refueling, 8 J-57 engines, a bomb load exceeding 70,000 pounds, true intercontinental reach from American bases. First flight, April 1952. Last airframe rolled off the line, October 1962. 744 aircraft total, and not one replacement has been built since. SAC pushed the B-52 beyond any peacetime logic. Operation Chrome Dome kept nuclear-armed B-52s airborne around the clock, guaranteeing a retaliatory strike even if Soviet missiles hit every American base simultaneously. In January 1961, a B-52 broke apart over Goldsboro, North Carolina. 2 thermonuclear bombs fell onto American farmland. One of them cycled through 5 of 6 arming stages. The document confirming this was classified until 2013. Vietnam changed the aircraft without changing the airframe. Modified for conventional carpet bombing, a single B-52D carried 108 bombs per sortie. During Linebacker 2 in December 1972, B-52S flew 729 sorties over Hanoi and Haiphong in 11 days. 15 were shot down, mostly by S-75 missiles. SAC adjusted tactics mid-campaign. The B-52 survived Vietnam, survived the Cold War, and in 1991 launched cruise missiles over Iraq from safe standoff distance. No longer a penetrating bomber, but a platform for weapons that flew the last miles alone. The airframe endured. Everything inside it changed, repeatedly. That distinction would prove to be the most important engineering decision in American bomber history. On May 1, 1960, a single S-75 missile ended an entire theory of survival. Francis Gary Powers and his U-2 fell out of the sky over Sverdlovsk at 70,000 feet, an altitude everyone in SAC had assumed was safe. It wasn't. And if a reconnaissance aircraft cruising at that height could be killed, so could a bomber. The logic that had driven American bomber design for a decade collapsed in one afternoon. The answer already existed on the runway. The B-58 Hustler had flown its first prototype in November 1956, built entirely around the premise that speed was invulnerability. A delta wing, 4 J-79 engines with afterburners, cruise at Mach 2.0 above 50,000 feet. The primary payload, nuclear weapon and fuel combined, hung in a detachable pod beneath the fuselage, dropped after the strike. SAC displayed the B-58 at every opportunity. Speed records, transatlantic records, a triple sonic boom over Washington on command. It was theater, and it was convincing, until you looked at what operating it actually cost. The crew of 3 sat in separate tandem capsules, with no physical contact between them during flight. The escape system worked, theoretically, at supersonic speeds. At the 1961 Paris Air Show, a B-58 crashed during a low-altitude display. 3 crew members died. The capsule system had not been designed for low-altitude ejection. Brake systems overheated on heavy landings, causing wheel fires. Early fuselage frames developed cracks along rivet lines. One B-58 required 3.5 times more maintenance hours per flight hour than a B-52. Specialists who could service it were scarce. When one wasn't available, the aircraft stayed grounded. 26 of the 116 aircraft built were destroyed in accidents, 22% of total production. The program lasted 9.5 years in service before McNamara's budget reviews in 1965 made the question unavoidable. What exactly had been purchased, and at what cost per delivered warhead? The XB-70 Valkyrie never even reached that question. North American's design promised Mach 3.0 at 70,000 feet, riding its own shockwave to reduce drag, a concept called compression lift. The program consumed nearly $1 billion before Kennedy canceled it in March 1961. The reasoning was cold and correct. The S-75 had already proven it could reach that altitude. ICBMs delivered the same payload cheaper and without a crew to lose. 2 prototypes were built for research. The second was destroyed in June 1966 when an F-104 starfighter collided with it during a publicity photo flight for General Electric. 2 men died. The first prototype flew until February 1969 and now stands in a museum in Dayton. No XB-70 ever carried a weapon. The fastest, highest-flying bombers America ever built left no operational legacy. What they left instead was a lesson. A single performance characteristic, pursued to its extreme, produces a machine optimized for conditions that will not survive contact with the enemy's next move. SAC was left with an aging B-52 fleet and no credible successor. The answer, it turned out, would have to come from a direction no one had seriously funded yet. Two answers emerged in parallel, and they were not the same answer. The first came from the Air Force itself. The B-1A program launched in 1969 with a specification that tried to solve everything at once: variable sweep wings, Mach 2.2 at altitude, supersonic penetration at low level, intercontinental range. The first prototype flew in December 1974. 4 aircraft were tested. In June 1977, President Carter canceled the program. The official reasoning: too expensive at $8.8 billion for 244 aircraft, redundant against what cruise missiles and ICBMs could already do. The unofficial reasoning: a different program, running in classified darkness, was showing results that made the B-1A look unnecessary. That program was stealth. Carter killed the B-1A and quietly funded what would become the B-2. Reagan reversed the first decision in 1981, reviving the aircraft as the B-1B Lancer, but with the performance ceiling lowered. Maximum speed cut to Mach 1.25. Payload increased to 125,000 pounds. 100 aircraft delivered by 1988. The Cold War ended before the B-1B ever flew a nuclear mission. Its warheads were removed under arms reduction treaties, and the aircraft was reclassified as a conventional strike platform. In that role, it excelled. Over Afghanistan, a single B-1B squadron flew 770 combat sorties and logged 9,500 flight hours in 6 months. But by the 2000s, structural fatigue, ejection system failures, and chronic engine problems forced the Air Force to retire 17 of its 62 active airframes simply to reduce maintenance costs. There is still no direct replacement. The second answer was built in secret and revealed to a stunned crowd in Palmdale on November 22, 1988. The B-2 Spirit looked like nothing that had come before. A pure flying wing, no tail surfaces, no vertical stabilizers, a shape designed not for aerodynamic elegance, but for near-total radar invisibility. Northrop had won the Advanced Technology Bomber contract in 1981. The program had consumed over $23 billion in classified research funds before the first aircraft was publicly shown. Congress planned to buy 132. They bought 21. Every B-2 is based at a single location: Whiteman Air Force Base, Missouri. Inside climate-controlled hangars that maintain precise temperature and humidity to preserve the radar-absorbent coating. After every flight, technicians inspect every square centimeter of the surface by hand. Combat debut: Kosovo, 1999. Flying 30-hour round trips from Missouri, striking targets no other aircraft could reach undetected. Libya, 2011. 3 B-2s destroyed 45 hardened aircraft shelters in a single sortie. Cost per flight hour: over $130,000. Total fleet: 21 airframes, each one irreplaceable. The B-2 proved that stealth worked. What it couldn't prove was that 21 aircraft constituted a strategy. A tool that exists in such limited numbers is not a force. It is a statement of intent, deployed only when the target justifies the risk of the asset. Every other mission went to something older and cheaper. That imbalance had a name no one wanted to say aloud: the gap between what stealth could do and what America could actually afford to field. Ось шоста частина, що витікає з фінального образу частини 5, геп між тим, що стелт може, і тим, що можна реально мати. Part 6 The Next Shadow. The requirement written in 2011 році was, for the first time in American bomber history, defined by what had gone wrong before. Not fastest, not highest, not most advanced. The long-range strike bomber program opened with one constraint above all others: affordable enough to build in meaningful numbers. The target price, $550 million per unit in 2010 dollars, was a direct response to the B-2. Everything else would follow from that ceiling. In October 2015, Northrop Grumman won the contract over a Boeing Lockheed Martin team. The approach that carried the bid, digital engineering, open architecture, a production model designed for modification without rebuilding the line from scratch. The aircraft that rolls off in 2035 can carry fundamentally different systems than the one that flew in 2023. Same airframe, different everything inside. For a platform intended to serve into the 2080s, that matters more than any specification on delivery day. Public rollout came on December 2nd, 2022, in Palmdale. The B-21 Raider's shape was immediately familiar. A flying wing, clearly descended from the B-2, but the differences were deliberate and visible. Deeper buried engine inlets, trapezoidal cockpit framing, a surface treatment that Northrop has not described publicly. The photographers at the ceremony were positioned at approved angles only. The underside of the aircraft was not shown. First flight, November 10, 2023, Palmdale to Edwards Air Force Base. First LRIP contract signed January 23, 2024. 5 initial production aircraft. As of early 2026, 3 flight test airframes are active. Planned bases: Ellsworth in South Dakota, Whiteman in Missouri, Dyess in Texas. First operational deliveries to Ellsworth, 2027. What is publicly confirmed: the B-21 carries the B-6112 gravity bomb and will integrate the LRSO cruise missile. It is designed for penetrating missions against defended targets, the same task the B-17 attempted in 1943 without escort. What is not confirmed: radar cross-section, engine specifications, maximum speed, electronic warfare suite. Unlike every previous American bomber program, no technical description has been released even after the official unveiling. The silence is a design decision. The name was chosen deliberately. Raider. For the men who flew B-25 Mitchells off a carrier deck in April 1942 and struck Tokyo knowing there was nowhere to land afterward, they went anyway. That lineage runs through every aircraft in this story. The B-17 crews who completed 9 missions and still had 16 to go. The B-29 pilots who knew the engine could catch fire on takeoff. The B-52 crews airborne with live weapons who understood that some orders, if they came, meant no return. The B-2 pilots flying 30 hours alone to hit a single building no one else could reach. The question that opened over Schweinfurt in 1943 has never been answered, only renegotiated. Each generation set a different price. The B-21 is the current bid. Whether it holds is not yet known.